Hey, this is Mr. Kingsbury, and today I just want to talk to you a little bit about transformations of absolute value functions. You can see I've got my heading good to go. It's Algebra 2, of course, is the subject that we are in this whole year. This unit is about absolute value functions. Specifically, we're looking at transformations. I am Mr. Kingsbury, as I mentioned before. Please put today's date right there and whatever period you have me. Our essential question is a little bit longer this time, and I apologize for that, but it was important to write it out just the way that I did. Our question is this: given an absolute value equation, how do I identify the transformations that have been made to the parent function and vice versa? Meaning, and then if I'm given the transformations, how do I write what the equation looks like after I've made all those transformations? It's not as hard as you think, but we need to know a couple things first. So for starters, we need to know what a parent function is. A parent function is the simplest form of a function. Think of it like, you have parents somewhere. People have parents, right? And all the other functions come from this one function. Everything else can be found by taking this one function and moving it around the graph. If you took the graph of this function, you can move it up, down, left, right, you could stretch it, you could make it thinner, you could do all kinds of stuff, and that would allow you to get every other function. Usually, this is accomplished. The parent function is found by plugging zeros and ones. Anywhere that you're multiplying something, you put in a 1. Anywhere you're adding or subtracting, you put in a 0, and it simplifies down pretty easy. The absolute value parent function is y equals the absolute value of x. And these are called absolute value bars right there. The general form is this. We've got y equals a times x minus c plus d. And I know right now you're going, whoa, 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 whoa. That's a lot of letters, bro. You're right, it is. And let me explain what each one does. This a1 on the front, this controls what we call the vertical stretch or compression. Basically, this guy either makes our graph a lot thinner or a lot fatter. Also, side note, if negative, it flips the graph over the x-axis. The c value here just moves things left and right. L-E-F-T. And the d value moves things up and down. If it's a positive d value, it moves it up. If it's a negative d value, it moves it down. Similarly, if it's a negative value over here, it moves things left. It's a positive value, it moves it right. There is one catch. There's a built-in negative right here. So when you plug in, for example, a negative value for c, you end up with two negatives that make a positive. If you plug in a positive value for c, that negative overrides it and it looks negative. We'll talk about that as we do some examples. So, in fact, let's just jump into those examples right now. So, let's start with interpreting something. Let's say I give you y equals 4 times x minus 7 plus 1. The first thing that you want to do is identify your a, your c, and your d. A is out in front of the absolute value bars. That's my 4. My c is going to be right here. This is going to be the tough one. It looks like it's negative 7, but remember, in the general form, there's a negative built in. So if I take that negative out, what's left is a positive 7. Some people say when you're interpreting a c value from an equation, it's the opposite sign. Hopefully you'll get used to that as the year goes on. And then lastly, our D value is 1. Then we can interpret this based off of our definitions here. So A is our vertical stretch or compression, right? 4 is a number that is larger than 1, therefore it is a stretch. So this will be a vertical stretch by 4. And maybe we should put a little off to the side here. If A is bigger than 1, it's a stretch. And technically, if A is between 0 and 1, I did not do that right. It is a compression. We don't worry about the negative. And what I mean to say is, if this was a negative 4, it would still be a vertical stretch by 4. We would just add this piece on. We'll do some examples and that will make more sense. Right now it's a little confusing. That's okay, just bear with me. Next up we have our C value of 7. 7 is positive, so that's going to be right 7. Or if you want to be really snooty, a horizontal movement to the right 7 units. You'll see that on our test, that's what it'll say. It is what it is. And then our D value is 1. 1 is positive, whereas the positive is up, so that's up 1. That's pretty straightforward. Let's try another example. Example 2. Y equals 1/2 times x plus 5 minus 3. Again, identify your A, your C, and your D. A is 1/2. D is negative 3. Include that minus in there. And then C, it looks like it's positive 5, right? But it's not. Remember, we got to change the sign. So this is actually not x plus 5, but if you will, x minus negative 5. So my C value is actually negative 5. So this D being negative, that means it's going down, so this is down 3. C being negative, that means it's moving left, so this is left 5. And then the 1/2, the 1/2 is between 0 and 1. And actually, I probably should make this negative 1/2, so let's do that. That means two things. The 1/2 part, ignore the negative part, the 1/2 part is between 0 and 1. So that means we've got a vertical compression by 1/2. And then also, remember what I said right here? If it's negative, it's also a flip over the x-axis. So what we'll say is flip over x-axis. So, that's what happens there. And it's just a couple of examples here. We will do a ton more in class, I promise. Because right now, many of you are probably going, I'm sorry, what? We'll make sure we talk about it in class, I promise. Okay? Actually, by the time, we'll talk about it in class. I need to do 2 more where we're going the other way, and I'm going to make them kind of quick. So let me draw in my lines really quick here. I never know how many sheets of paper I'm going to use, so I don't draw the lines until I absolutely have to. So no worries. What we're going to do here is I'm going to give you some transformations, or I'm going to put some transformations down here, and then I'm going to interpret them and write the equation that comes from them, starting with the general form. So let's say we go left 4, up 2, and there's a vertical stretch. Let's do a vertical stretch by 3 and a flip over the x-axis. I'm going to identify A, C, and D. I'm going to do that. Left 4. Left or right is my C value. Left is negative, so my C value is going to be negative 4. Up and down is my D value, so up 2 will be a D value of 2. Up is positive, so that's positive 2. A vertical stretch by 3. A takes care of the vertical stretch and compression, so my A value will be 3. And then it says flip over an x-axis. That means the A value will be negative. So I'm going to take that 3 and make it negative. My general form is y equals A times the absolute value of x minus C plus D. I know I said that a little fast. I'm sorry. I'm going to just plug these things in. My A is negative 3. And then I put the absolute value of x minus my C. C is negative 4. And then it goes plus D. D is 2. The only other thing I would do is right here, this double negative, I can make a plus. So my equation would be y equals negative 3 times the absolute value of x plus 4 plus 2. And right now, you are probably going, what on earth did he just do? I realize, guys, it looks really confusing, and I'm throwing it at you very quickly. So trust me when I say we're going to practice this in class, and you will get the hang of it. By the time the year comes around, you will be so good at this, it will be ridiculous. Let me do one more here. Let's do down by 5. Let's do a vertical compression of 1/3, and let's go right 1. So I'm going to identify A, C, and D. For those of you wondering, there is a B. We're choosing to leave it out. I will discuss it in class briefly. Essentially, the B value makes things very confusing, and we're going to leave it out as much as possible. I think when it comes to solving, we might leave it in, but as far as transformations, we're not even going to touch it. So let's see, down 5. Up and down is my D value. Down would be negative, so D is going to be negative 5. Vertical compression, that will be my A value. So my A value will be 1/3. And then it says right 1. My C value handles left and right is positive, so I'm going to put a positive 1 here. Once again, I start with the general form of the equation. Y equals A times the absolute value of x minus C plus D, and I will substitute in Y equals, my A value is 1/3, times the absolute value of x minus C is 1, close my absolute value bars, plus D is negative 5. You can either leave this as plus negative 5, or if you're a little anal retentive like I am, you'll just change it to negative 5 like that, and that is my equation. Not a whole lot to it. With some practice, it will make so much more sense. Right now, a lot of this probably is just really weird, and it doesn't seem right in your head. That's okay. If on a scale from 1 to 5, 1 being you have no idea what's going on, and 5 being you could teach this, if you're somewhere between a 2 and a 3 on this, like you're starting to get it, but it's not quite there, you're right where you need to be. Do not worry. I will see you in class. Have a good day.